Log on, tune in, find out. Another good idea from Cambridge.
And our speaker today is Professor Joe Perry, who's spoken here before. I think since you first came, you've had the good fortune to retire, is that right?
That's right.
And the peak of his ambition now is to be selected for the Norfolk over 50s second team in cricket.
Yes. We're playing next month, I know.
Right. And he was playing yesterday, that's why he arrived a bit later. Joe's his professional career has been on the statistical work on ecology, and as you see, he's going to talk on the ethics of food production and GM crops today. A little sideline: the church he goes to, this will show you how ecologically minded he is, has no electricity, so they meet by candlelight. Apparently it's a small church in the middle of a field with no electricity. St Michael and all angels in room. Right. So if you want the real experience, the medieval experience, you can join him one Sunday.
You'd be very welcome.
Anyway, Joe,
certainly you might double the congregation. How would you go?
Okay, so I have given you a handout, but I'm not going to explicitly address those ethical questions. Probably haven't got time. I thought I'd just talk round the subject of GM, and then you've got those to sort of have a look at and ask yourselves questions later on. So we start off in Cambridge, where Crick and Watson studied, and so it's a young science in some ways, genetics, and particularly plant biotechnology is a young science because DNA was only discovered just over 55 years ago. So how does it differ from what we would normally do? Normally in conventional plant breeding, we would take maybe two varieties of the same species, but two different varieties, and we cross them. And then we're shuffling about thousands of genes in a fairly random way that we can't predict exactly what's going to happen, and then we would select from those plants ones to go forward to the next generation. Whereas in biotechnology, what we would be trying to do is to be more precise. So we're taking a single gene, a gene that we think we know what its function is, and we're putting that single gene into a plant. And of course it could be a gene from a different species. So here they've taken a gene from the firefly, which has the trait of glowing in the dark, and that trait is put into a tobacco plant. And I'm not a molecular biologist, but I'm told that this is the way that it's done. But don't ask me any questions about it.
why would you want a tobacco plant that glows?
I think that's a good question. I think that's really just a demonstration of what you can do, a physical demonstration, so that you can see, oh, yes, that's what's happened here. But now I'm going to come on to sort of try and describe what sort of traits are typically put into plants. And the first thing we see is that GM has been consumed for about 20 years, well, 15 to 20 years, and it's growing in acreage, and it's growing just as much now in developing countries as it is in industrial countries. Apologies for the non-alignment here, but you can see, for example, in China, in 8 years you've got a tenfold, over tenfold increase in the area of crops. Lots of farmers, so it's not just large farmers in China, small farmers too, and the same in India. And potential uses in less developed countries. Yes, there are potential uses. particularly because pests and diseases are more rife in tropical countries, for example. And so if you can breed resistance to those pests and diseases into your crops, that's a good thing. And that has been done, certainly. The other things that are mentioned, improved quality, drought, saline tolerance, fixing nitrogen, those are coming along in the next tranche of GM crops, but they're not with us yet. And for many years, opponents had said, well, okay, there is potential, but that potential has not yet been realised. And in fact, a couple of good reports, one from the Royal Society in 2000, transgenic plants in world agriculture, and this one actually, there's a flyer for this in your packs, I note, from the Nuffield Council for Bioethics. And these are the sort of crops that people transform: maize or corn, canola, which we call oilseed rape, and this tends to be insect resistant. We'll come to that later. So does cotton and soybean. So the traits that we can put into those crops, we'll move on to those now. First of all, let's have a look at herbicide tolerance. What's this? Well, usually a crop will be susceptible to competition with a whole range of weeds, broadleaf weed or grasses, maybe of different types, and a farmer would often have to use a different herbicide to control each of those classes at different times of the year. Well, if a crop has been modified to be tolerant to herbicide, usually that will be one particular herbicide, and it will be a broad spectrum herbicide, meaning that it kills most green plant material. It would be the herbicides that you use against these weeds. So it's tolerant to a broad spectrum, which means that if we treat the system with that one chemical, for example glyphosate, sometimes called Roundup, then all we get left with is the GM crop itself, because it kills all the other weeds. And that's a simpler system for the farmer, maybe more profitable. But of course, it's highly efficient. And although a farmer might say, well, this is what we want to do, we want to kill weeds, don't we? On the other hand, weeds are the bottom of the food chain for the species which inhabit the countryside. So in our arable ecosystem, particularly in the UK, where we're not like the USA, we don't have vast areas of prairie land and equally vast but different areas of wilderness. We have our countryside, our semi-natural habitat is sort of interposed with our farmland in a mosaic. So our areas of outstanding beauty are right in the middle of our farmland. And therefore, for us, it's a real issue that herbicide tolerant systems are so efficient that they can lead to reductions in weeds, and that in turn, organisations like English Nature and the RSPB are very concerned about the decline of farmland birds. So there are many arguments, particularly in EU law. This is now going to cause problems because the applications to grow herbicide-tolerant plants are coming through the EU authorities, and under EU law, a crop can only be grown if it's shown not to have deleterious effects on human health and the environment. But of course, you can argue that these might have deleterious effects on the environment. So there is going to be a difficulty over legislation, and there are moves now, I think, to try to push out the legislation so that each member state of the EU can deal with this sort of problem under its own herbicide regulations and deal with it, deal with the balance between farming and biodiversity in the way that it wants to. I think slightly less controversial maybe are the insect resistant crops which express a toxin called Bacillus thuringiensis. It's a natural toxin. In fact, it's used by one of the few pesticides used by organic farmers. It's effective against Lepidoptera, comes in various forms. So if you've got any caterpillar pests, as you often do on cotton, then this is a way in which the plant can express its own toxin and resist insect moth pest attack. And the good thing I think about this is it has genuinely led to a great reduction in the use of pesticides. The ability to be selective is an important offshoot of the technology. So there's been a lot of reduction in poisoning from insecticides, particularly in developing countries. Also, we're not just we are certainly talking about large agrochemical companies that market this, but not exclusively. And there are systems in China which have been locally developed, which again is a bioethical concern many people have. And we've got the possibility of virus resistance. Plants get diseases, and they get virus diseases just as we do. And we can put virus resistance into plants. Ecologically, there are some dangers with this, particularly if a particular plant variety has a near relative which is weedy. Now, if you haven't got a near relative, then there's not the scope for gene flow between the GM crop and the environment. So, for example, with herbicide-tolerant maize in this country, we've got no weeds in the UK that are relatives of maize. So there's no issue with the genes flowing from the herbicide-tolerant genetically modified maize to native weeds. There is an issue that they could go from the herbicide-tolerant maize to organic maize or conventional maize, but not weeds. But with virus resistance, if you did have some weedy near relatives, you may well not want gene flow for virus resistance to go into those relatives, because then you'd have weeds which were resistant to virus. And actually not much, I think, is known about how susceptible weeds are to virus. Much more is known about crop diseases, but not much about weed diseases. And it may well be that you would be creating quite a problem. So there are these risks that we need to be thinking about. The next tranche of crops include crops. Here, for example, in this New Scientist editorial, they're talking about Monsanto producing a crop which is a healthier form of soya. So manipulating the levels of particular oils to give a healthier option. And we also have the possibility to engineer crops so that they express vaccines. And there are two issues here. One is just a description of a debate in one of my local churches where I used to live in the year 2000, pointing out the fact that somewhat unusually there was a positive outcome for the motion. We believe that genetic modification represents a positive step forward for humanity. Now, given all of the unrest and opposition to GM crops that has been in this country, and that's quite unusual. And I think the reason was that the debate was framed in terms of medical research, and there's no doubt that for medical research, GM has potentialities that John Bryans has already discussed. Whereas there's a lot less sympathy for GM food. So, but sometimes the two issues overlap, and this is another. This is an example of one of those, which is so-called farming, which is farming with a pH. So, producing pharmaceuticals from crops which have been modified, in this case, to express a vaccine. And in fact, the company that did it was doing that work in 2000 actually went bust during the all the anti-GM feelings that were being published in the media at the time. But farming is still a live issue. It has some risks, certainly, because there is the issue of what crop you would use to express the pharmaceutical. Now, if you use a food crop, there's the danger that you would get pharmaceuticals into the food chain through contamination. And there's one thing I think certain about contamination is that it will happen, that it's virtually impossible to segregate 100% crops. There's often accidents, and you often find small percentages of GM being imported technically illegally into the EU because they haven't been approved as a result of contamination, often in North America. But the one of the main drivers, I think, that's probably going to happen in terms of the acceptance or otherwise of GM crops is food security. And here I must say that, broadly speaking, not completely, but broadly speaking, I would agree with Michael Rice, who spoke yesterday, said that when he'd been sat on committees, the food safety aspect of GM was not, for him, much of an issue. That basically he believed that it was safe, certainly in the applications that he'd seen. Broadly speaking, I'd agree with that, but certainly there is much opposition to GM, and there's been very little change within Europe over the last 10 years. And I think, although this is not an ethical argument, I think as a pragmatic argument, things are changing, and things are changing in a way which will impact on us, not just in GM, but in other ways. And the fact is, I think food has been getting cheaper. In my parents' generation, my father would be spending over 20% of his income on food. Now here's us, between 5 and 10%. We have got used to cheap food. We've got used to surpluses. We've got used to fields in set aside. And I think all that might be changing. for a number of reasons that are all seemingly coming together, and coming together quite quickly. For example, climate change. It's only about a year ago that we had these. It's funny how quickly you forget, because I'd forgotten until I looked back at the slides. Big floods in mainland Europe, and reports that these floods were going to cause real problems with wheat prices going up through the roof. And yes, actually that did happen. More generally, I mean, there are predictions that we can do of areas where we can do certain things now, where we won't be able to in the future as climate shifts, and often these are, we've got other predictions of new pests that will gain a foothold in areas that they didn't have before, and that will also change our ability to farm. But this is showing you that the area that's viable for wheat now will be A, reduced, and B, shifted to different areas in the future. And that has also led to this this particular news item here, where someone's talking about the necessity to try to deal with a situation that may be a crisis situation, and the sort of conflict between maybe an ethical concern or concern about safety and the basic desire to have enough to eat. Simultaneously, GM has become embroiled in the biofuel debate. There is a push now, as oil becomes scarcer, for us to grow biofuel. So again, and as we'll see, we're going to be cutting down the area that we farm for food, because some of that is going to go for biofuels, which are more sustainable, carbon neutral. GM can help there by improving the efficiency of those biofuels. But again, you can see that's also leading to food, well, less land on which we grow food, so a greater pressure on food. And I don't think it helps that we seem to be planning to build plants to burn wheat in instead of a sensible crop, maybe like sugar beets. But that's what we seem to be doing. And this article here is emphasising that if you happen to be in a country like the Philippines, where you're importing food rather than exporting it, you're in a much more serious position, because with the land that's going into biofuels, that food price is going to go up, and there'll be less available surplus for humanitarian aid. So is it true that prices really are going up? Well, they certainly appear to be. There's a trend since the year 2000, in fact they've probably doubled over, well, 2 years. I think they're about £150 per tonne now, so that's certainly about double what it was during the early part of the decade. And land prices, agricultural land, where I live in Norfolk, has gone up from about £2,500 per acre to about £7,000 per acre now. My next door, well, we neighbour a field. That field has had wonderful brown hares on it, living in it for many years, because it's been insecticide for many years. and the farmer didn't want to grow a crop on it. It's poorly drained, it's on the clay lands, not well drained. Well, he's now going to drain it, and it's coming out of set aside and going back into a crop. So we're not going to get our nice brown hairs in the future, but well, it will be in production anyway. So that's a change. And at the same time, if we look at trends over decades, we can see that the Green Revolution, mainly as a result of improved plant breeding, increased cereal production. But then there came a plateau, and in order to take off again, we probably will need a new form of technology. GM has the potential, which it hasn't fulfilled, but it has the potential to help with that. And at the same time, our intensive agriculture depends upon oil, and oil is used not just in tractors but to make fertilisers, pesticides, and for distribution. So if the price of oil goes up as it is, the price of food is going to go up too. Add that to the well-known problem that the population of the world is expanding and has not yet, although it is believed it may well plateau in the future, but it has not yet reached that. There's clearly a major problem there. And the amount of land on which we're able to farm has, as the population's gone up, and as a lot more land is used for industrial purposes and for cities, the amount of land to grow crops on has gone down. And in China now they're beginning to be concerned. So all of these drivers are pointing in one direction, that there is a major problem expected of food availability. And then we ask the question, can GM help? Now, critics would say, rightly, it has not helped yet, because the herbicide tolerant and the insect resistant crops, which account for 90%, probably over 90% of those used at the moment, have little perceived benefit for the consumer. They're okay for the farmer, but not for the consumer. But the supporters would say, well, if they are helping with agricultural efficiency, that's good for everybody, and there is the potential to help more. Well, what about organic farming? Is that not an alternative? Several articles here, they're all saying, well, organic agriculture does not produce the same yields as conventional agriculture. We could switch to organic farming, and then although it's arguable, a switch to wholly organic might be more sustainable. So it might help us in the long term. But we would have to plough up a lot of marginal land, which would itself reduce wildness and biodiversity. And I don't think there's much doubt it would lead to a great deal of starvation, because we wouldn't be able to feed the world population that we can feed at the moment. So there are problems in pushing that as a solution. So with GM, I think we have the situation we have with a lot of major technology. They have pluses and minuses. They have benefits and risks. So maybe instead of completely rejecting them, we should look at them on a case-by-case basis. And that's how the risk assessment is done. And there certainly are risks. And here are some of them. Here are the major risks.
Food safety. Is this stuff as safe as food that we normally eat? Is it more or less? Are there problems with allergenicity? Is the genetic transformation stable? Those sort of issues. I've mentioned the genetic effects, that's the gene flow, which isn't necessarily a bad thing in itself. It's the consequences of gene flow that we do look at and try and evaluate. I mentioned with the herbicide tolerant crops that there's maybe nothing wrong per se with the genetic modification, but that it can have indirect ecological effects. And then there's all of the socio-economic and bioethical issues. For example, this lady wants to save seed, so wants to sow, reap the harvest, but then use some of that harvest as seed for the next year, which with licensed GM crops may not be, is not possible. So there are issues for subsistence farms. What happens in Europe? Well, within Europe there is now a statutory way through of approving both imports of food and feed and applications to cultivate. So there's a panel of about 20 European experts, and they meet in Italy and go through these dossiers. So for those people who are concerned about food safety, yes, there is an enormous concentration on getting it right, and this panel looks purely at the scientific aspect, doesn't look, in fact is not allowed to look at the bioethical implications. And the situation in Europe is quite complex and quite political. I mean, it started off, North America went through its own approval process and started eating the food, but there was a lot of resistance within Europe, and effectively, although it approved a few products early on, there was then a kind of a halt. And in fact, the USA claimed to the World Trade Organization that Europe imposed a moratorium, and they took that to the WTO, and in fact they have won, and right now, really in 2008, we are just, Europe has been told by the WTO that it faces really very heavy fines if it continues to have what the WTO sees as a moratorium. The problem being, as this USDA report says, that the debate's highly politicised, and there are contentious issues in the EU, but they're not actually related to human health and environmental safety. And within this, the European Food Safety Authority has been sort of set up to assess risk and to publish scientific opinions on risk, and it was hoped that that would help Europe to approve, but in fact what's happened is that there's been a trickle of products that have got approval, about 9, and in the meantime there are 10 more dossiers with the European Commission and about another 25 under consideration. What happens is that certain member states are in favour, a lot of member states are fairly neutral and will be guided by the science, and some member states are completely opposed. Hungary, Austria, for example, and indeed now France. And often, as in the French case, you've got President Sarkozy who feels that his environmental credentials are not good in some respects, particularly because he is an advocate of nuclear power. So to sort of provide a balance, he's very hard on with an anti-GM stance. And in fact, he's going against his own scientific establishment, but which demonstrates, I think, that it's fairly highly politicised. And at the same time, the member states are putting a lot of pressure on for better and better quality of evidence, which is, I think, the comment that Michael made yesterday, that the level of evidence is now needs to be very high. A large amount of data needs to be gathered, which is a shame, as he said, in one sense, in that it is only the big companies that can now afford it. So here, for example, is the average dossier of information. Now there are about, I think, 6 of these ring binders, and they're each about that thick, full of data. So you can see that there are parallels between the Church of England idea of marriage and the way that we now do risk assessment within the EU. So this is the only actual sort of slide with any theological content on it, I think, because it seems to me that there are 3 questions that we need to ask ourselves, and I'm not going to try and provide the answers, but at least I'll ask the questions. So, should we do it at all? Are we playing God? If we do it, can we do it in a way which is compatible with our responsibilities as stewards of the environment, and certainly with justice for the poor? I mean, is there any way in which GM could be compatible with justice for the poor? And very importantly, I think, how do we present our views on GM? I think this is a problem in any really controversial area. There are very few people who are independent, and I no longer consider myself as independent. I was independent when I first got into this area, and that was, I think, 1998, because I came in not as someone who develops the crops, but someone who was assessing them in the farm scale evaluations. So when I came in, I had very little idea pro or anti. And I think it's impossible to stay in an area for some time as an academic without getting some ideas of your own about whether you support it or not. And I think that causes problems. Certainly it's caused me problems. You know, when I've been to meetings, I think it's very difficult in such a controversial area to provide a very independent or unbiased view. But let's, having had a go at some opponents, let's now have a go at the large multinationals. Certainly, I would say that the idea of gene patenting I regard as anathema. Certainly, as I've said, a public relations disaster in the first tranche of GM crops, and they I think compounded that by not really being very sensitive to particularly the views of Europe. Concerned with HT, again, they've been very slow, I think, to understand what were the differences between North America and Europe. Now, there's nothing wrong with making a profit. I mean, we all
we use mobile phones, for example. The companies that produce those do so to make a profit. People seem to be a little bit more worried about the large ag biotech multinationals making a profit, and the reason is it's because it's concerned with food. So they're not about feeding the hungry, and there's a real concern, I think, that there is too much food power now in the hands of very few large multinationals. Of course, as I've already said, unfortunately, by regulating it so strictly within Europe, we're actually
playing into the hands of a process in which the large multinationals become even larger because they need to be in order to fund the development. But there have been further public relations disasters, bullying of individuals over intellectual property rights, such as Percy Schmeiser, the Canadian, and that large companies seem to support this narrowing of seed diversity, which really can't be a good idea for food security. GM has got good potential. One of the flagship products is golden rice, being held in hand here. It's golden because it expresses vitamin A, so it's a vitamin A supplement in a staple food, and it was developed publicly by Ingo Tricus, Swiss academic, but he needed permissions from many companies to use licensed processes. He got those, I think, partly because the companies were very keen to improve their public relations. But it's not developed by industry. It's now under development by the International Rice Research Institute, and it doesn't have many or any environmental negatives, and could not have been developed with traditional methods. It's still under development. It's taking longer to develop, I think, than they originally predicted and they would have liked. But in fact, most of the early advances in GM were made universities, like this one, publicly funded research institutes, and even now in the developing world, a lot of research is done outside of industry. This, I think, is a good model. It's a technology foundation funded by the Rockefeller Foundation, which is attempting to solve problems locally, because GM, if you're going to use it in tropical countries, you really need local solutions. You need varieties which are meeting local needs and which have been developed locally. You can't hope to import varieties that have been developed for temperate countries, for example. So taking the science into that country, doing it there, hopefully on a fairly small scale, with the cooperation of local farmers, I think is a good model for the way forward. Well, what sort of future traits can we expect? The ones coming through here, Pioneer and DuPont, are talking about, well, increased yield, which will certainly help. Nitrogen uptake, which means that we will use less fertiliser, which is good. Improvements in nutrition and healthier composition of oils. Similar set from Monsanto, who now accept that the first generation of products didn't benefit consumers or processors. So they have a second generation, including drought resistance and again, fortified food. Biofuels, well, we may have mixed feelings about them. And they're expected to come through within the next 3 to 5 years. Further possible problems on the horizon. GM animals that now within the European Food Safety Authority we are starting to develop risk assessment guidance for. GM salmon had quite a lot of publicity, and there were real worries. They were modified to gain weight faster than conventional salmon. Of course, in doing that, they would then be able to outcompete native species with possible large marine ecosystem change if they escaped. And let's face it, I think escape is inevitable. We cannot expect to ring fence. We have to take the worst case scenario. If if there's a possibility of escape, they will escape. Recent New Scientist article said that in fact these worries that we had might not actually be as serious as we thought, because whereas what happened in an enclosed environment, in a tank, may well not happen in a more natural environment. And there are echoes here of the monarch butterfly controversy, where Bacillus thuringiensis was shown to affect the monarch butterflies in the lab, as you might expect it would. And there was quite a big controversy about it, and it led to at least 5 or 6 or 7 or 8 3-year studies in North America, which then showed that the actual ecological problem which you got out there wasn't as great as you might have thought from lab work. So certainly reinforces the notion that it's very important not to just go from the lab, but we need to look at field trials as well. Other likely future issues. Well, I've mentioned these traits as if they are single traits, but of course they can be put together. So you can get several genes in the same plant, several modifications in one plant, and that's called gene stacking. And there one might be a bit concerned that there could be interactions between the various traits. That certainly needs care. I've mentioned this one. Coexistence within Europe between conventional, GM if it is approved, and organic agriculture. All of the rules need to be worked out and shown that they will not unduly harm any of the proponents of the other agricultures. Accidental introduction, we've dealt with that in farming. Of course, we need to ensure that if we do start growing biofuels, that is safe as far as human exposure to it goes. GM trees, well, pollen from trees goes much further than plants in general, so we've got problems with gene flow there. So quite a few problems to solve with the technology. And just in the last 10 minutes, I just want to touch on a really common concern that people have, which is they seem to have a real mistrust, taking a gene from one species and placing it in another. And there seems to be quite a divide between scientists, particularly molecular biologists, who don't really see what the fuss is all about, and the general public, who certainly for whom this is one of the main issues. I remember doing a talk to Harpenden
well, it was the Harpenden Ladies form of the Rotary Club. I can't remember the name of it now. But that was their main issue. What they saw as bizarre, taking a gene from a fish and putting it in a tomato. That kind of issue. Here we've got a slide from the farm scale evaluations. One side is GM, one isn't. It would be very difficult to tell without actually spraying Roundup on those two halves and seeing which halves died, which was which. An old colleague of mine, Keith Davis, thought that he had come up with the answer of what makes people disgusted about this process. And his idea was that actually we are still thinking in a very a way which is dominated by the Greek idea that species are these unchangeable types. Whereas he said most of us, or most of the general public, would accept that since Darwinism, since Darwin, we now do believe in evolution, for which there is, I think the man in the street would probably agree, a great deal of evidence. And Darwin said, well, it's not a species, just a statistical abstraction. It's the individual which is unique, and of course we know that in evolution species do change and move through time and space. So what Keith Davis was trying to say was, well, if we really did believe as Darwinians rather than as Greeks, we wouldn't maybe be so disgusted, particularly when we consider how many genes we've got in common. I mean, both me and my daughter have about half our genes in common with a banana. So, for that reason, I think the molecular biologists don't see much of a problem in taking a gene from one organism, putting it into another, because so many of these genes are conserved anyway. And the other thing that they will argue is, well, this is Derek Burke's slide, look, we've actually been doing this for many, many years. Plant breeding is not just about what I said on the second slide, taking two varieties of the same species and crossing. It's not always that. We've been pushing at the boundaries between species for many, many years, and examples are, well, the best barley to produce our wonderful English beer was came from mutation in the Winfrith atomic pile, I think it was. Was it as long ago as 1927? Well, there we are. And we so effectively we've been doing this, crossing wheat and rye to produce what is now our basic bread making wheat triticale, and so this is just really a continuation of that process. So with that I'll stop and be very pleased to answer any questions.
Good. We're seeing climate change going on outside at the minute. I'd like to kick off. Thank you, Joe, very much. Perhaps I can start. Why do you think the reception of GM crops is so different in Britain and North America? Or has been so different historically?
Well, that's a difficult one, because it may be partly to do with the fact that the public saw the technology as an American technology. It certainly had a lot to do with a really good campaign
during 1997 in the media, and quite hysteric headlines, but that were very, very successful in planting seeds of doubt in the consumers' minds. I mean, bear in mind the fact that you've got concern from scientists during the 1990s themselves, and it was the scientists really during the 80s that set up the regulatory hurdles, or the committees that led to the regulation of GM technology, because the scientists expressed, you know, is this as safe as we really think it is? So let's look at it. So they looked at it, and throughout the 90s you got Michael Rice, who was here yesterday. He mentioned a booklet that he produced with a guy called Strawn and Rice, and it was a fantastic booklet, very, very informative. Went through the issues, and this was, I think it was published in 1996 by the research councils, who genuinely wanted people to look at what they were doing and to be aware of it, but to reassure them too. And a very good leaflet. I've still got it at home. I still often look at it. The public, by and large, were not interested. They didn't regard it as an issue. And so the Research Council, particularly John Innes in Norwich, went out of their way to try and sort of push the idea, look, you know, this is what we're doing. We're not trying to hide anything, and it's not unsafe. By and large, the public weren't interested, but then in 1997, it coincided with the field trials that were going on within the UK, because these crops were almost at the end of the regulatory process, and a lot of organisations, non-governmental organisations behind the scenes, were quite opposed. So you've got Greenpeace and Friends of the Earth, and I think they ran a brilliant campaign. They fed information to the tabloids, and not just the tabloids. Both the Independent and the Guardian were vociferously against, and I think, you know, partly it was the fear that technology was being foisted on us, and so there was scope for investigative journalism, and certainly the gene flow. I think the government committees always realised that gene flow, so-called contamination, was going to be a problem. But the consequences of it, they thought, were not going to be a problem. So, for example, Rosie Hales, the young Oxford ecologist, wrote an article in Nature which showed other articles with her boss, Professor Mick Crawley of Imperial College, that yes, there was going to be gene flow, but once the genes were out there, there was no selective pressure on them, and therefore no reason to think that they were going to lead to, that they would escape, but they would not survive. So in general, you know, those populations would just die out. And the government knew there was going to be gene flow, but this became a big issue. It was very much sort of hyped up that this contamination would lead to superweeds, etc., etc. And I don't think that at that point there were insufficient scientists who were prepared to come out, it was said, stand up and discuss the issue. And so the campaign was really very one-sided. Scientists weren't prepared to stand up and make the case for, and the consumers gave it a complete thumbs down. And then the supermarket said, well, we're not going to, it became sort of a badge of honour to say we are non-GM.
And so I think a very good campaign was waged. The question is, what will happen? I think, you know, in 2 or 3 years' time, probably, we're going to get the whole thing coming back, because we're going to have, food is going to go up in price. The WTO are going to put yet more pressure on Europe, and the herbicide-tolerant crops, I think, are going to come back, certainly into this country, for approval. And then the question will be, will there be the same public antagonism, or will it be different? Now, if I had to bet on it, I wouldn't, I wouldn't like to risk much money, because I think it could go either way. But I think probably that the journalists now have sort of let it run its course and have seen it's not quite as hysterically awful as some of them said it was going to be. So I think probably there wouldn't be the media hysteria, and I think probably from what I can gauge of public reaction, the public are a lot less entrenched than they used to be. But that may be wishful thinking on my part.
I think Dennis first, then we'll move back.
Yeah, just to add a comment, I wonder if another difference between the reception in North America and Europe is that generally, I mean, sociologically, North Americans have a much higher trust in science and scientists still compared to Europeans. I mean, when it's been measured, you know, they just generally have a higher respect for science. And I think that still is maintained in more recent studies. So I just wonder if, I think that probably has some part of the story as well. They just believe what the scientists tell them. In Europe, there's this very deep suspicion. If scientists tell you something, it's probably a lie. So I think that's quite deep in their thinking.
Exceptions, evolution.
Yeah, that's...
Do you think Ted...
I'm talking about technology.
Do you think Ted would agree that North Americans have been selected to be risk takers because they riskily left Europe and migrated to set up their own country? I don't know.
Perhaps before we take the other question, I'll just ask Jonathan, who is a North American and did a degree in ecology.
I don't know if this is related to that at all, but and perhaps it's just my own experience, but as I recall, the minority who were strongly opposed to GM crops in the States actually it tended to have far less to do with sort of the health risks to human beings and so forth. Perhaps because they were convinced by the scientists there wasn't some fundamental problem with transgenic crops, but it did have to do with the more practical things of biodiversity and the influence of large corporations like Monsanto, particularly in the developing world. Those, for me, were the two main issues that even still in my mind are the reason I query genetically modified crops. So it seems like even the issues there were different. And of course, the majority ignored those issues anyway. But anyhow.
Yes. I'd just like to pose a question about whether the campaign against GM in this country wasn't here, but certainly from the Antipodean experience, the agribusinesses like Monsanto were almost their own worst enemy in terms of some of their ethical and business practices that occurred during this time, which gave them they became the big bad bogey because that's how they behaved in a lot of so it was very easy to dislike them when somebody's coming along and saying this is bad. It's coming, and it must be bad because it's coming from a bad company. And I'm just wondering whether there was a big chunk of the public opinion based on the fact that people really didn't trust the agribusinesses. Yeah, now listen to the headlines instead.
Well, I think you're right, and also I found myself at a loss to understand how a big company with a slick, profitable operation could sort of be so dumb at public relations.
Yeah.
I remember, when we were discussing the results of farm-scale evaluations at the Royal Institution, the results came out in October 2003, and Monsanto, instead of using the English guys to field questions, they brought over a guy with a pronounced North American accent who said, farmers are only doing what farmers want to do, which is to kill weeds, isn't what's wrong with that kind of thing. It's a completely sort of, I mean, this experiment had gone on for 4 years because organisations like English Nature had begged the government to give them time, have an experiment to look at the effects on wildlife, because we're very concerned about our wildlife in our countryside. And you know, the company brings over someone who says, well, only bugs kill them anyway. Weeds. Actually, a lot of English farmers were saying that, but it would have been better to have an English farmer saying it. So I couldn't believe how naive they were. There we are.
Something with gene flow, some of the legal actions they took as a result of gene flow, for instance, that again created the same negative publicity that they were just the big bad burglars.
I think we're first at the back and then we'll work our way forwards. Yeah.
Just going back to what you were saying about how farming in America is different to over here, that they have these large-scale prairies, whereas we tend to have small mosaic fields. Would there be a very different effect on biodiversity over here than they have in the States with these GM crops, because they have these large-scale areas of untouched wilderness that act as reserves, whereas over here, because we have such small-scale farms, there might be a very different effect.
Well,
ecologically, I mean, I just want your opinion.
I mean, there is a different effect ecologically, but also there is a different species pool for us and Americans to be concerned about. You know, I mean, they may be concerned about their wilderness species. I think actually they're also quite concerned about songbirds, and I think actually even in the prairies they do have quite a lot of farmland birds. Surprising amount. But I think the situation is very different in the UK, and I think one of the differences is that within our countryside, you know, it's not just farmers who live in our farmlands. It's articulate middle-class barristers and professionals who love walking on Sunday mornings if they don't go to church, or maybe they love walking after they've gone to church, and love the animals that they see in the country, and are prepared to be very vocal in support of them. Yeah.
No, I think that's...
You see, if you go into the middle of East Anglia, you'll have the farming community, but you'll also have the rest of the community. It's a very different atmosphere to if you go to the middle of the prairies, everyone works in farming. And if you say anything anti-farming, well, you don't get much support. But in this country, you know, if you go into the pub and talk about, oh, these farmers have been spraying near me and my daughter's got asthma, and you'll get a lot of sympathy. So it's a very different sort of situation.
Our writers all live in Manhattan.
But you know, some have likened Europeans and the North Americans to the Greeks and the Romans, with the North Americans playing Romans to our Greeks, you know. So we think a lot in Europe. We're maybe not all that effective. But the Americans maybe worry a bit less and get on with it, you know. But I would be inclined to urge as well that in thinking about why things went wrong and how things went wrong, in addition, I agree with everything that has been said. In addition, I think it would be wrong to miss out that in most people, it seems to me anyway, and certainly in the younger people that I deal with, there is something that I can only think is a kind of a wish to respect the integrity of organisms. You know, that actually makes up quite a bigger part of our psyche than we normally give it credit for. We often associate it with extreme greens, but we often don't think that maybe we're entertaining quite a bit of that ourselves. For instance, just in my experience, which isn't all that great, this comes to the fore most easily if you suggest maybe we will GM forests, GM forest trees, yeah? And it seems people say, oh, gee, I don't want to go walking in GM forests, you know, I want to walk in natural woodlands. It's bad enough that I have to walk in semi-natural woodlands, but GM woodlands, that's the last word. So there's something else creeping in there that we shouldn't ignore. But going back to issues, ethical issues that maybe should concern us very significantly now in Europe, I think we're looking at two things in relation to GM in particular. One is, yes, the control of food, and particularly with respect to developing countries. Control of food is a big one, and I don't know any way around that except to have that as public good research, the development of those crops, as you were saying. And then the other one is the question of opening the European market to GM products, particularly from Africa. You know, I think of it in that way, because as long as Europe protects its markets from GM products that could be produced in poorer countries, we're really having a very negative impact on developing countries. So I think that for me, there are big ethical questions for Europe in relation to those two things: GM research for appropriate crops for developing countries, and then opening our markets.
Well, I would agree with everything you say, and particularly the first point that you made. I think when you said, yes, there is this desire of people to have natural things and be surrounded by natural things. I think having been in the area now for sort of over 10 years, I now no longer feel I can actually easily connect with what the average person that hasn't been in it for 10 years is thinking. So I'm particularly pleased to hear that comment, because I think it's very difficult after you've been subjected to arguments for so long to detach yourself and know what the people on the ground are thinking.
We had a question at the front.
I'm speaking from a school perspective, really. Having taught biology, at the present moment I've got an A-level student. And what I think why the response, and I think it's also true of the embryology bill, the nonsense that is spoken by ordinary people, which they pick up about what is going on genetically. And I don't think there's enough emphasis, I don't know if you concur with that, in schools on these issues. Some years ago there was a whole ethical element brought into biology syllabuses. It didn't seem to be it doesn't seem to be in the same level syllabus at the moment. But of course they're learning about transgenic systems and so on. They're learning all the technical details, but there's no reference to any ethical issues. And the general run of people are not clear what is actually going on scientifically, even in the simplest terms. And how you get this across to people, you're talking all sorts of nonsense, which is just scientific nonsense, because they're just not clear in their own minds what is going on. And if they knew, they'd probably understand it better and agree with it. So it's throwing it back to schools.
Well, I certainly would agree that I've done a lot of schools talks, and they're a joy to do, because the kids are completely open-minded, and yeah, I mean they're just a joy to teach, because you can get across concepts that you might meet with resistance in a. I mean I can remember probably about 8 years ago now that I did a schools talk in the morning, I did a public meeting in the evening, and the difference in the attitudes was intense. Most of the adults had made their minds up. There were very few in the audience that hadn't, which is a shame. And you do have to be very careful, I think. But I think it's very, I think it's very rewarding, and that is the place to operate. If you want to try to discuss, you know, a technology like GM, I think you have to do it in small groups, schools, church meetings. That's, you know, Women's Institute. That kind of a small gathering that you can address. And the only other thing I can say is that I once did a schools talk, and the headmaster gave me a really hard time because I think that he thought I was coming to brainwash and indoctrinate. And in fact, I deliberately took the young team that we were working with. So they, you know, there was me, and there was 3 of them who were about, I'd say, between sort of 20 and 30. It was good because we made DNA in the classroom. You know, you can make it quite easily from onions, and it's quite easy to do. And but he was very antagonistic towards me. He said, "Well, you're academic. Why have you come mob-handed? Why have you needed to bring all these people with you? You know." Well, the reason was I thought the kids would be closer to the age of my team, and I wanted them to show, not have me talking. But he misinterpreted it completely, because he obviously thought, you know, I had an agenda. So I think you have to work very hard to demonstrate you haven't got a fixed agenda.
Joe, you mentioned the I think appropriate analogy between GM food and traditional hybrids, plant hybridization done from phenotypes. To what extent do European farmers sort of experiment themselves by growing various hybrids on their farms? Do they do this?
I don't think they do it much.
It's just all over the place in the U.S. People do this everywhere.
Really?
You know, they grow corn only pretty much in Pennsylvania, where I live. The wheat farming takes place in the Midwest, but I'll go, you know, if I'll drive through a farm that might be a half a square mile or something, and there'll be 3 or 4 different, on the highway, I'll pass 3 or 4 different plant hybridization signs of what they're doing.
Now with maize, you get it much more than with other crops.
Okay.
So yes.
So maybe that's what
and in
it is.
Spain, they have, you know, various sort of land races that they use. Yeah. So I think maize is a bit of a special case, actually.
Okay.
And it's so much of a sort of a hybrid crop. Yes. Yes, and that was part of the controversy over the genetic contamination of the Mexican maize land races.
Okay.
That they were, you know, that these very old varieties were becoming the bedrock of hybridizations were becoming contaminated. But I don't think it happens much for other crops, and indeed, you know, we have quite a strict regulatory procedure in which we have variety trials in order for a variety to be registered. So it can't be sold in the EU unless it's gone through this procedure. And in fact, if anything, I think people are becoming a bit worried that the genetic variance is the diversity is much lower than it ever was. You've certainly, in things like apples and pears, you've got traditional farmers and growers who are trying to maintain the old varieties. And there's a lot of interest in that because a lot of people would say that these varieties have got special, a much wider diversity of taste and qualities and disease resistance than a lot of the newer varieties have got.
So I was wondering if there's attitudinal differences here, because of the willingness of American farmers to try different hybrids that are classically obtained. Maybe they say, okay, well, we'll try these genetic modifications too.
Maybe.
I'll just say, as somebody who's grown a lot of wheat, and one of the problems is in this country, we always sell the crop by variety. You could not sell 100 tonnes of wheat without specifying where it had come from, what variety it was.
Okay.
So we don't have the choice, and I think that's the other point, Joe, that we don't have the choice to just grow some obscure variety that nobody's ever heard of. We'd have been pushed to sell it. So we don't just sell maize or wheat or barley, we sell a variety of maize. And the buyer would want to know what that variety was. So I think that's a restriction that maybe you don't have in the States, that we do have in this country.
I couldn't say.
Would you say that in Britain it's not really the farmers who are the problem in accepting GM? Would that be right? That it's at a higher level in society. The farmers are not rejected.
Yeah, it's consumer really.
Yeah. Yeah. I think farmers are prepared to try it, yeah. Certain farmers.
Just before I go to Jonathan, I might say that just up the road here at Girton College, they have an amazing collection of apple trees of a wide variety of ranges. It's one of their glories, which is not very widely known. The other glory is that actually students are allowed to pick them free. Go to Girton if you like apples. Jonathan.
I was just curious, following up on this, actually, is there any danger about losing the diversity of crops, actually, by using GM crops? Because that's what happens then, you have everyone growing precisely the same crop, so perhaps a new disease develops that then all of it's susceptible to.
Yeah.
Is that a genuine danger, or is that overblown?
I think it's a genuine danger, yeah. Yeah, I think it's a genuine danger. Particularly, you know, we've got climate change now. You know, our areas are going to be subject to different climate, different pests, different diseases, maybe. So there may be greater challenges than we've faced in the past. But I think it's always a danger, you know, to narrow the diversity. Yeah.
For the last 5 minutes, can I just direct you to a slightly different question, which comes from one of your very early slides, where you showed world population increasing to about double what it is now. Then the UN thinks it may flatten off simply because as people get more affluent and healthcare is better, they have fewer children. So people think it will flatten out to 11 to 12 billion, about twice what we are now. Jonathan and I have often had discussions about whether we can grow sufficient food for everybody to live at a reasonable level, maybe not quite so obese as we are, but you know, at a reasonable level, using conventional crops. Do we need GM just to feed people at a population of 12 billion? Do you have a view on that?
I think my view would be the same one that Derek Berger sort of expostulated in the past, which is to say that the major problems are undoubtedly inequitable distribution of food. Yes, agrees with that entirely, but that's still no reason to throw out a technology that might be capable of helping the situation. So it's not that I would sort of support GM because it's the answer, and it may only be 10% of the answer, but it would be more that I would defend it against people who wanted to get rid of it by saying, well look, you know, it's true that we as a species are a fallen species and we don't distribute our food the way we ought to, but that's still no reason to want to go and throw away a valuable possible future tool.
Right, but the deeper question is the carrying capacity of the Earth big enough to grow any food?
Right.
Do you have a view on that?
I don't know enough about it.
No.
I'm not sure.
Because I think there's some papers, aren't there, that you've read that say that is the case, some that say it's
I
not.
would say that we perhaps already exceeded it, yeah.
Yeah.
Setting aside even questions of biodiversity.
Yeah.
I mean, you've already alluded to the problem that the tastes of the developing world are changing, particularly in China and India, and they are seeking to move to more meat eating, and if you eat meat, your agricultural efficiency goes down because you need more land to convert to meat than you would the same amount of staple plant food. So I think that's a
much roughly.
yeah. So that's a complication, and maybe if we all stopped eating meat, I still don't know what the equation is, and I guess it depends on sociology as much as, and where the population does level off, if it does level off.
Good. Well, that's exactly 3:30, so I think probably we should draw to an end now. Let me thank Joe again, and then I'll hand over. I don't know if Jenny and Rodney want to make some concluding remarks, but let's thank Joe first.